When we talk about alien technosignatures, we're forced to do it from the position of looking at our technology and our speculation, and then asking ourselves if we could look for that and detect it when we look into the heavens for alien life. In short, you need to have some idea of what to look for in order to start searching. Often people tell me that aliens might use unicorn technologies to communicate, which solves the great silence, and that we're still using primitive things like radio, and they use some advanced communications method that we don't yet have. But the problem with that is since we don't have those technologies, we have no idea what to look for. And it's true. Evidence of alien life might be right under our noses and visible everywhere, except that we simply don't know how to look for it. Little effort is spent in SETI on looking for what you don't know, but you can stumble on things. An example of how this unfolds is Tabby's star, where the star was behaving strangely, but in a way that would have been consistent with some type of Dyson swarm or a partial sphere, at least initially. It later showed to be inconsistent with that, but to this day we do not have a solidly complete explanation of what exactly is happening with that star. But within this is a possibility. What happens if you see something that you hadn't thought of or expected that leads you to the possibility that you might be seeing something of alien origin you do not understand? This is very possible. If you see some bizarre phenomenon happening in space that you cannot find an explanation for, but you also can't figure out how nature could be doing it, you might be seeing the activities of an alien civilization without understanding why they are doing what they are doing. We simply aren't advanced enough to understand. And this is somewhat terrifying because you could see something extremely powerful and counterintuitive that really should not be. We have a candidate for that, Brzycki's star, where the star is somehow producing elements very far up the periodic table outside of what nature as we know it does elsewhere. This does not mean it's aliens doing it, it's just that maybe, just maybe, that's it. But it could also mean that we're seeing physics in nature that we only have largely hypothetical ideas about. In this case, the island of stability that's thought to exist above any elements we've synthesized, but we haven't actually seen in nature or the laboratory. It may even be a 50-50 proposition. If we ever do see evidence of alien civilizations, it may just as likely be that we will see something we don't understand as it is something we do understand, at least sort of. But Tabby's star and Brzycki's star are not the only candidates we have for a potential alien technosignature we do not understand. One of the others has become obscure since observations of it were first made in 2017. And while I have made a video on this star before, there have been some developments in the story since that haven't resolved the matter, but add some interesting twists to the story. The star system is known as HD 139139, or the Random Transitor, and it consists of what's thought to be a gravitationally bound double star system. Both stars are main sequence stars, about 350 light-years out in the constellation of Libra. One of them is a G-type star, like the Sun, though a little larger and brighter, but very close in temperature, and the other star is a red dwarf. Both stars have similar movement, known as proper motion in astronomy, which is why they are thought to be gravitationally bound, and the age of the system is about 1.5 billion years. The observation in question was made across an 87-day period, August 23rd to November 20th, 2017, by the second phase of the Kepler mission. Kepler also discovered Tabby's star, incidentally, and this particular instrument was a photometer. It would stare at a single area of the sky with a somewhat narrow field, but that still included many thousands of stars within its field of view, and then would watch to see how they brightened and dimmed over a long period of time. The Kepler datasets reveal a lot about other star systems. The main intent of the instrument was to look for dips in brightness that occur when exoplanets transit across the face of their parent star, and Kepler discovered thousands of these. But it also saw things like sunspots on other stars, variable stars doing all sorts of interesting things like pulsating, star flares, and many other things. It remains an important pool of data to this day, not only for astronomers looking for exoplanets, but astronomers studying the behavior of other stars themselves. Citizen science was also employed to look at the mountain of light curves of these individual stars for dips from exoplanets or anything that might be of interest to scientists to take a deeper look at. Most of it was mundane, or at least as mundane as the discovery of an alien exoplanet can be. But there were a few light curves that made no sense that caught the attention of the citizen scientists digging through the data. HD 139139 and Tabby Star were two of these, though there actually were more oddities that, as far as I know, were never followed up on. In the case of HD 139139, dips were seen that in all ways looked like exoplanets, except for one problem. They were random. Planets orbit their star, and as such, if you watch long enough, if you see a transit, you will see the same planet transit again and again as it completes orbits. To visualize this, imagine you're sitting in space looking towards the sun. Every 365 days, you will see the Earth pass in front of the sun from your perspective, over and over. That's what Kepler was seeing. That periodic behavior is important in identifying exoplanets because nothing else does that. You're not being fooled by star spots or anything to do with the parent star. The problem is, HD 139139 looked exactly like planets passing by, but they weren't returning. They were not periodic, but they didn't appear to be star spots either. Unfortunately, the two stars in this system are close, which confounds the observation. You can't know which of the two stars was producing the dips. The ideas put forward to explain it included a bunch of planets chaotically perturbing each other's orbits to seem random, a planet in the process of disintegrating, weird asteroids producing dust somehow, abnormal star spots that were very short-lived, and aliens doing something we do not understand. There was also a rather odd aspect to this. About 0.5% of stars in the Milky Way are in a position that allows them to see Earth transit the Sun. Everything has to be lined up, just so, to see transits. But in the case of HD 139139, they would see Earth transiting, though only just so. It wouldn't be centered. Still, if they had a Kepler type of photometer, they'd see us. They might also be looking at us specifically because their star system includes a G-type star, and so does ours. So like us, stars of the same type as the Sun are a great place to look for aliens because you already know life is possible around them. And if you have a Kepler-type photometer, maybe they do too. So instead of sending out a radio signal, send out visible light semaphore that the instrument will see. In short, show a signal that shouldn't be there, and that's how you say hello with potentially no other commonality. Interestingly, one thing that was noted was that all of the transits, except one, appeared to be planets all of the same size, with the other one being roughly twice the size of the others. The original paper reporting this was by Rappaport and colleagues. There will be links to all papers mentioned here in the description below. After reporting the finding, the story went cold for the most part, which is not unusual. If you want to observe something again, that can take months or years to get the telescope time. The first development was from Breakthrough Listen, and it's not much of one. They used the Green Bank telescope to take a look in radio and see if there were any transmissions coming from the system. This is common in SETI. Whenever something weird comes up that could be aliens, the SETI astronomers tend to swing the radio telescopes to it and see if there is anything there. That was done with Tabby Star, in fact, and Oumuamua, but no radio signals were seen. It was the same story with HD 139139. Nothing was seen in radio. Worth a shot, but nothing. Weirdly, when Tabby Star was looked at in laser, however, something was seen. There actually was a detection, the only one in that study of hundreds of stars for SETI laser signals. Very strange, but the researchers chalked it up as an errant cosmic ray hitting their detector. So I'm assuming someone looked again after that was reported to see if they could acquire the signal again. It would not be good if that detection were discarded just because it was a detection, and an assumption that it wasn't a candidate signal because it would simply mean that any time you pick up an alien signal, you assume it isn't one and move on, meaning you have no chance of ever finding an alien signal. You will always talk yourself out of it. This is an even bigger problem with unknown or unexpected technosignatures. The other development is that HD 139139 has been observed again by R. Alonso and colleagues using the CHEOPS instrument. This is interesting because they quite frankly saw no dips at all. The phenomenon has disappeared. This could mean one of three things. The first is that whatever happened when Kepler observed the star has since stopped. This is interesting because it may be that the cause was rogue planets, and that there was this passing group of planets completely free-floating in space, and all the same size except one, that we just happened to catch as they were passing in front of the star, and they have since moved on. Another option here is something in the solar system, as pointed out in a paper by Schneider at the Paris Observatory, that it could have been a grouping of solar system objects, Kuiper Belt objects or asteroids or the like, passing in our line of sight, though they'd need to have been pretty compacted in with each other to affect only the single star system, but not impossible. A second option is that Kepler had a glitch, and the data for this star was bad. But this is actually unlikely, because Kepler did not show this glitch at any other time in its run. Can't rule it out, however. The third option is that the objects are indeed orbiting the star somehow, but the observation window of CHEOPS unluckily was during a period where they were not transiting. This has low likelihood, like a 4.8% chance, because the observation window was rather long, but again, can't be ruled out. So HD 139139 remains on the list of potential technosignatures we might not have thought to look for, though in fairness, French astronomer Luc Arnold did propose geometric shapes, and even a louver passing in front of a star as a way to signal other alien civilizations. But this wasn't that. This was just an otherwise natural-looking group of transits doing something extremely strange, and ultimately would have been ambiguous as a technosignature anyway. Aliens probably would have known that, and chose a more direct method of visual messaging. Kepler only observed a very tiny patch of the sky, and found a number of strange, misbehaving stars. I've always wished that we would have manufactured hundreds of Keplers, and pointed them in all different directions, which the TESS spacecraft actually does. It is the successor to Kepler, but it's limited by its generality and the distance that it can effectively look. It's designed for close exoplanets, but looks at almost the entire sky, and some limited data is possible for further stars. A good thing because all of the weird anomalies Kepler saw were far away, but fundamentally a ton of Keplers would be interesting indeed. Anyway, the search continues, and someday we may well see something so strange that we can't explain it with nature or aliens. Wouldn't that be interesting? Thanks for listening. I am futurist and science fiction author John Michael Godier, currently inching closer to spooky season. There's a lot to cover this time around, and be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.